Okay, which graph does not represent a function of x? These are really easy. I think we should be professionals on these things. So Jim Kidd and look at basically vertical line crosses it twice, not a function. So this is not a function. That's what they want. Crosses it once, once, once. It is a function. Slash they don't want that one. Once, 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 once. And I mean it crosses it once, crosses it once. Each time I draw a vertical line, it crosses the graph the arrows once. Those are not functions. I'm sorry, those are functions, but they want the one that's not a function. So this is the one that is not crosses it twice. Okay, this is really easy. You see, basically we don't want to see this. If we see that, where this one goes to 2, or this one goes to 2, or this one goes to 2, it's not a function. So let's see what happens here. This one is a function. The mapping represents why is the function x? Because, let me see, it's a 1-to-1 for sure. Let's see now. There are more x values different now. Each x value, yes, each x value corresponds, or x goes first and then y. Here, these are pretty easy. Basically, once you go to add some points, these coordinates to this data here, and basically we don't want the x's to repeat. We don't care what the second ones, we don't even care what they are. We don't care about any of these. All we care about is the first ones. Okay? If this data here is a function, which of the following could be a? Select 2. So we put in here, if we were to add it right here as 2, 4, you see how the 2 is to repeat? Not a function. So it can't be added. If we were to add a negative 2, and what number is that? Negative 1. You see how the x's don't repeat? That's part of the function. That's correct. That's the one that we would like. Because they want the 2 of them that would be a function, right? Function x's do not repeat. Do not repeat. Negative 3. If we were added negative 3 here and negative 1, you see how the negative 3 repeats? Not a function. 4. We put a 4 here for this one. It would repeat with that one, so not a function. Put a 6 here. The last one, we'll put a 6, negative 2. CV 6, 4, negative 3, negative 2. I'm sorry, 2. They're all different, so that would make it a function. Those two still make it a function, or keep it a function. Which represents a function. This says y, a function of x, and so forth, which is a function. So basically, we're looking for this. You see that? Not a function. See that? Not a function. I'll give you why, because at 0.35 goes with 0.70, and at 0.35 goes with 1.10. You see how that comes out twice? So it's not a function. Coming over here, not a function because of this right here. Not a function. All these go to 1. These each go to 1. Perfect. It goes to 1. There's no 2 arrows coming out here, and that's your answer for this one. Again, we don't. Okay, so which order pairs could also belong to the functions like 2? We don't want. Where's the data? Am I missing something? Oh, it's up here. Okay. We don't want the x's to repeat. As long as they're all different. Look for negative 4. It can't be that one. Negative 2 can't be that one because it would repeat. 6 can't be that one. So it has to be these two right here. 9 and 4, add them here, do not repeat.